Today we're going to look at L'Hopital's rule, and in order to use L'Hopital's rule, we need to have something that's in an indeterminate form, and yeah, we're going to use it to evaluate limits. So, L'Hopital's rule is basically as x approaches anything, if I'm doing a limit, if I have f of x over g of x and it yields some form of 0 over 0 or infinity over infinity, positive or negatives on any of those, then I can, instead of doing the limit as x approaches a of f of x over g of x, I can do the limit as x approaches a of f prime of x over g prime of x. So again, the condition here in order for this to work is it has to be an indeterminate form, 0 over 0 or infinity over infinity. So first thing we want to do here is turn on our pen, and we're going to plug in 1. So we try a direct substitution first, and we get ln of 1 is 0, times 5 is still 0, and 1 minus 1 is 0. Hey, an indeterminate form. Therefore, L'Hopital's applies, and once I know that L'Hopital's applies, I'm still going to do the limit as x approaches 1. I'm going to do the derivative on the top and the derivative on the bottom. Now, don't confuse this with the quotient rule. This is simply another cancellation method, and I'm not taking the derivative like in terms of finding the slope of this particular curve. Okay, so now I'm going to do a direct substitution. I get 5 over 1, which is 5. Perfect. Here's another one, and if I put in 0, I'm going to get 1 minus 1 over 0, so that's a nice little 0 over 0. L'Hopital's applies. So I'm going to take the derivative. Derivative of e to the x is e to the x. The derivative of e to the negative x will be negative e to the negative x. This changes to a plus sign between them. Derivative of x is 1. I can do a direct substitution now. I get e to the 0 plus e to the 0, which is 1 plus 1 is 2. Okay. So sometimes we have to repeat ourselves, and sometimes we have to repeat ourselves. So this is an example where we might have to do L'Hopital's more than once. So as I plug this in, I'm going to get negative infinity squared over e to the negative infinity. So that's going to be positive infinity. We agree infinity over infinity. Okay, so therefore L'Hopital's. So I'm going to start by, I have the limit as x approaches negative infinity of 2x over negative e to the negative x. I still have infinity over infinity if I plug in negative as I do the limit of x approaching negative infinity. So, therefore, L'Hopital's again. Okay, and I can continue to take L'Hopital's until I get something that I like, so long as everything I'm taking the derivative, as long as every time I double check to make sure I'm getting an indeterminate form. Okay, at this point I can plug in, this is negative infinity. So at this point I'm getting 2 over e to the infinity, so now I'm getting, e to the infinity is going to also be infinity. I'm getting something growing significantly faster on the bottom than the top. This comes out as 0. Okay? So again, as a reminder, L'Hopital's only applies if I'm in a form of 0 over 0 or any kind of positive or negative infinity over positive or negative infinity. Our other indeterminate forms, though, are 0 to the 0, 1 to the infinity, infinity minus infinity, 0 times infinity, and infinity to the 0. Those are all versions of indeterminate forms, but L'Hopital's doesn't work for any in that format. If I see one in one of those formats, we can still use the rule usually, but we have to adjust them. We have to convert them to something that's 0 over 0 or infinity over infinity with any version of plus or minuses. So here I have the limit of, as x approaches pi over 2 of 3 secant x minus 3 tangent x. We know if we plug in pi over 2 into secant or tangent, both of those functions would be undefined. So right off the bat, I'm having basically, this is that format of infinity minus infinity. Okay, so it's indeterminate, but I can't apply L'Hopital's yet because that's an indeterminate form that we don't like. So what we want to do instead is get it into a form we like. We know secant's the reciprocal of cosine, and tangent is like sine over cosine. This is where all those trig identities you did last year come into play. So the limit as x approaches pi over 2. 3 minus 3 sine of x over cosine x. When I write it like that, I now have a fraction, so that's a good sign, and pun not intended because I have sines and cosines. Now I'm going to plug in pi over 2. I get 3 minus 3, so that's a 0 on the top. Cosine of pi over 2 is also 0. Therefore, L'Hopital's applies. So I can do the limit as x approaches pi over 2, and then I'm going to take the derivative on the top. Derivative of the top will be negative 3 cosine x. Derivative of the bottom will be negative sine x. Now I'm going to plug in my pi over 2 to do a direct substitution. I get 0 on the top and negative 1 on the bottom, which is a-okay. One more for today. And that's the limit as x approaches infinity of x squared over x minus 1 minus x squared over x plus 1. We can all agree that, again, if I'm using my shortcuts from Algebra 2, this would be top-heavy, and so would this one, and so we'd end up kind of with this infinity minus infinity action again. So I'm going to start by getting a common denominator. So I have the limit as x approaches infinity of x squared times x plus 1 minus x squared times x minus 1. Then I really should all be in big set parentheses. Limit as x approaches infinity of x cubed plus x squared minus x cubed plus x squared over x squared minus 1. Okay. So I have the limit as x approaches infinity. My x cubes are going to cancel. I'm going to have x squared on the 2x squared on the top, over x squared minus 1. At this point, you might use some shortcuts to evaluate it, but since I am working with L'Hopital's, we are going to go all the way. Limit as x approaches infinity of 2x squared over x squared minus 2. I right now have an infinity over infinity. Therefore, L'Hopital's applies. So I'm going to have the limit as x approaches infinity of 4x over 2x. I still have infinity over infinity, therefore L'Hopital's again. When I do it again, I'm going to have the limit as x approaches infinity of 4 over 2, which is just 2. Final answer. And that concludes this video. Hope that helps.